Okay, we have 6 questions today. We don't have time for an intro. 31. Given below are the 4 ways by which zinc metal and hydrochloric acid were reacted at room temperature. In which way is hydrogen gas liberated with the highest speed? Here are the factors affecting the rate of reactions. We are talking about rate of reactions here. 1. Surface area of reactants. The bigger the surface area, the more space there is to react. For example, if you cut a 2 by 2 cube into 1 by 1 cubes, initial 16 square centimeters of surface area turns into 32 square centimeters. So the smaller components of a certain sample gets more surface area, the smaller it gets. Example, powder has more surface area than granules. 2. Temperature at which reaction occurs. When the temperature gets high, the kinetic energy, by the way, temperature is the measurement of kinetic energy, like how fast the particles in something moves is temperature. When the temperature gets high, the kinetic energy gets high as well. Kinetic energy is energy stored when an object is moving. Particles of reactants hit each other in a much higher rate, resulting in a higher rate of reactions. The opposite happens when things cool down. Keep in mind that most reactions have an optimal temperature, especially biochemical reactions, as in like after you get over some limit of temperature, the reaction speed slows down. Then concentration of reactants and pressure for gaseous reactions. When concentration is high, the amount of reactants is high. Therefore, high concentration results in faster rates. The opposite happens when it is diluted. Then we have presence of catalyst. Catalysts are the substances that increase the rate of reaction without being chemically consumed during the reaction, like enzymes or platinum in nitric acid manufacturing or salt in rusting. So the answer is going to be 4, zinc powder plus concentrated hydrochloric. 32. Between a strong acid and a strong base, what kind of reaction would occur? When a strong acid reacts with a strong base, it typically results in a neutralization reaction. In this reaction, the acidic hydrogen ions, between H+, from the acid react with the basic hydrogen ion, which is OH-, with the basic hydroxide ions, OH-, from the base to form water. Additionally, the remaining ions from the acid and base combine to form salt, not just table salt, we can be other magnesium chloride, things like that as well. The reaction can be represented by the following general equation. H+, strong acid and strong base, OH-, turns into water and salt. For example, the reaction between hydrochloric acid and sodium hydroxide produces water and sodium chloride, commonly known as table salt. HCl, NaOH, H2O, NaCl. This reaction is highly exothermic, meaning it releases a significant amount of heat energy. Exothermic is releasing heat, you feel the heat. Endothermic is absorbing heat, you feel cold when you touch it. It's also complete, meaning it goes to completion. No H+ or O- ions going to be floating around, they are going to be completed. Result in the solution that is neutral in pH. That means 7. Neutral 7. So like what is neutral 7? So answer is going to be 1, and exothermic neutralization reaction occurs. Sorry if I'm going really fast because we have 6 questions today. That's why. A conductor carrying an electric current I is kept perpendicular to a magnetic field. Perpendicular is 90 degrees. Magnetic field as shown in the diagram. Horizontal lines indicate the direction of the magnetic field, the direction of the force. They are asking about the direction of the force acting on the conductor. So, in these kind of situations, there are 2 things that comes to my mind when talking about electric current, magnetic field, force, all these things. It's the right hand grip rule and the Fleming's left hand rule. Remember right hand. Right hand grip rule is used to determine the direction of the magnetic field around a current carrying wire. To apply this, as you can see in this picture, you hold a wire that is current carrying, and the direction of the current, you point your thumb into it and you curl your fingers around this wire, and the direction your fingers curl is the field of the magnetic field. Okay, then we have Fleming's left hand rule. Left hand. Fleming's left-hand rule is used to determine the direction of the force. Direction of the force, remember, that's what we are looking for. Experienced by a current carrying conductor in a magnetic field. In order to do this, you get your left hand and you get your thumb. Your thumb is the force, your index finger is the magnetic field, and your middle finger is the current. We can eliminate the right hand rule due to forces being a factor. In the right hand rule, we are not talking about the force. Using Fleming's left hand rule, we can align index finger to the direction of the magnetic force and the middle finger to the flow of the current, and thumb would be force. And if we apply this to the question we have here, get your left hand and point to the direction of the magnetic field using your index finger. Point it. And you can see it's in the right. And the current, which is shown by our middle finger, is going to be flip up, as if you're like flipping someone off like that. And by doing that, where would your thumb rest? Thumb is going to be shooting into your phone or your computer, whatever you have in front of you, right? Force is going to be inward, like into the plane, right? So like you're shooting at it, into it. So the correct option is going to be into the plane of the paper perpendicular to the pen. So answer is 34th. Under normal atmospheric pressure, a pure block of ice at temperature of -10 was heated at a uniform rate until it was turned into liquid water, and then sometime after the water started to boil, which graph correctly indicates the variation of temperature of the system with time. When ice gets heated, the temperature drops until it hits 0 Celsius. Then it comes to the melting point, which is the same as the freezing point, which is in water, it's 0 Celsius, which will be represented by a uniform angle upwards from 10 to 0, like we show in the second option. Until it hits 0, it's going to be uniform. When the melting point approaches, the additional heat is used to break the intermolecular bonds. Intermolecular means two molecules, H2O and H2O, the bonds between those H2O and H2O. Intramolecular is the bonds between the atoms in the same molecule. Okay, so intermolecule is two molecules. Intermolecular bonds between the water molecules, so that heat doesn't get registered in the thermometer. So this solid ice, the bonds that we have solid ice in the bonds, their bonds get broken, turns into liquid. This process requires energy. This heat is not registered in the thermometer. Okay, we call this latent heat of fusion. The heat absorbed by the system without changing its temperature while the change of state is taking place is known as latent heat in general. Okay, when it is from a solid to a liquid, it is known as latent heat of fusion. And when it is liquid to a gas, it's known as the latent heat of vaporization. Solid to liquid, fusion. Liquid to gas, vaporization. In a temperature time graph, latent heat is shown by a straight line. Okay, straight line on the x-axis, like we can see in the second option. When the temperature reaches 100 Celsius, the liquid water turns into gas. This also requires latent heat of vaporization, so the temperature does not get registered in the thermometer. Okay, 35th question. Considering the following statement represented regarding natural rubber: A, it is a linear polymer. B, isoprene is the monomer. And there are cross links among the chains. Okay, let's talk about polymers and monomers first. Large molecules formed by the joining of a large number of small molecules with another is known as a polymer. Poly means a lot in Greek, like a little things. They get together to make a big thing. They bonds together. A monomer is the little thing. Okay, monomer is the structural unit of polymer. Polymers are made out of lot of monomers bonded together. Mono means one in Greek. Okay, a linear polymer is a polymer that is bonded in a straight line, one after another. So A is correct. Rubber is a linear polymer. And a natural rubber is made from isoprene. molecules bonded together. So B is correct. Natural rubber does not have crosslinks among the chains. Okay, crosslinks are given using a process called vulcanizing. Sulfur is used during this process. So C is wrong. Answer is 2. Only A and B is true. 36th. Corrosion of iron can be controlled by keeping an iron in contact with the prevalent metal M. What is the half reaction to which the metal M is subjected here? Let's briefly talk about corrosion. To get the chemical reactions, you can look at the screen. I'll just talk about it in a more simple way. Corrosion is known as a redox uh, reaction. It's a reduction and oxidation. A reduction reaction occurs when some atoms or molecules gain electrons. An oxidation is when other atoms or molecules lose electrons. Okay, so both of these processes are happening when it comes to corrosion. In order for corrosion to happen, we need three things. Okay, one, an anode that easily gives up electrons. We have iron, it easily gives up electrons, and we have a cathode that easily accepts electrons, that we have oxygen. And lastly, you need an electrolyte solution. Electrolyte means solution like water with ions inside of it. Okay, you may have seen a lot of metals iron rust after you let it out in the rain, or the iron fences near beach get rusted really quickly. Okay, in this one of these redox reactions occur. After this redox reactions occur, iron turns into hydrated iron, which is ferric oxide Fe2O3 H2O, or we call it rust. Rust is hydrated iron 3 oxide, okay, or ferric oxide. Like I said, these factors are accelerated by catalyst like salt. Remember the near the beach, iron near the beach, and acidic conditions also increases rate of corrosion. Okay, let's talk about the question in hand. Using bivalent metals to control corrosion is called a sacrificial protection, where a more reactive metal than iron is placed on the surface of the iron. Okay, we have a cathodic protection and an anodic protection. In the cathodic protection, the more reactive metal like zinc or magnesium undergoes oxidation, releases electrons. This process is represented by half reaction, zinc into zinc 2 plus and 2 electrons. Anodic protection is the iron that acts as the cathode and undergoes reduction, which is getting electrons, right? Gaining electrons. This process is represented by the half reaction. We have Fe2 plus and 2 electrons, they get the 2 electrons, then becomes Fe. So iron anodic protection, the iron acts as a cathode and undergoes reduction, gaining electrons. This process is represented by Fe2 plus and 2 electrons, and it becomes Fe. This sacrificial protection method is used commonly in things such as galvanized steel structures, where a layer of zinc is applied to the iron surface to prevent corrosion. The answer is going to be number 1, M solid into M2 plus Aquinas to 2A. Okay, that's it. Don't forget to subscribe.